Good morning, sir. We are from Group I, and we are going to explain about the assignment question. So I'm Lim Li Heng, and I'm going to explain about the question 1, part 1 and 2. So for the part 1, we have the equation 2r plus 1 equals to cos theta. So we make the r equals to cos theta minus 1 over 2. And we make the r as the f theta. So we get the equation f theta equals to cos theta minus 1 over 2. So for the symmetrical test about the x-axis, we use f negative theta and it is equal to f theta. So it is symmetrical about x-axis. About the y-axis, we use f pi minus theta and it is not equal to f theta. So it is not symmetrical about y-axis. About the origin, we use f pi plus theta and we will get it's different with f theta. So it is also not symmetrical about origin. So for the part 2, we make a table like this and we find the value of r using the formula r equals to cos theta minus 1 over 2 for every theta. So we will get a graph like this. So I think that's all for my part. I will pass to my group mates, Akila.
My name is Nur Akila binti Muhammad Tarmizi. I'm going to explain about part 3 and 4 of question 1. For the graph r plus sine theta equals to 0, it has been drawn on the same diagram of polar grid. Sine theta is bring to the right side, so r equals to negative sine theta. Next, table of theta and r has been drawn. Theta is started with 0 until 2 pi with increment of 1 over 6 pi. So, each point of r theta has been drawn on the polar grid. The graph has been drawn on the polar grid. The difference in radius is 0.2. Next, we can obtain the intersection points between the graphs. The intersection points are r equals to negative 0.067, theta equals to 1 over 6 pi, r equals to 0, theta equals to 0 degree, r equals to 0.8, and theta equals to 308 degree.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izwan. Today we will discuss about question 2. Question 2 is asking about to find eigenvalues and find eigenvector for the largest eigenvalue. Okay, for this question, we have matrix B, and first we use characteristic equation, which is B minus lambda I equal to 0. Don't forget to put determinant. And here we just write our matrix B minus lambda identity. Identity here is referred to the size of our matrix, which is 3 by 3 and equal to 0. Here we need to multiply lambda to the identity, and then we get this and equal to 0. Next, we use the formula of determinant, which is our matrix is 3 by 3, and then we get negative 1 minus lambda, 2 minus lambda, negative 1 minus lambda, plus 0 plus 0, minus here 0 plus 3 1, negative 1 minus lambda, plus negative 1 minus lambda, 1 1, and equal to 0. And then we expand minus here to this expression, and we get negative 1 minus lambda, 2 minus lambda, negative 1 minus lambda, negative 3, negative 1 minus lambda, minus negative 1, negative lambda equal to 0. Here we have 3 terms that contains same factor, which is negative 1, negative lambda, and we factorize out negative 1 and negative lambda here. and then 2 negative lambda, negative 1 negative lambda, negative 3 negative 1 equal to 0. And then we expand and simplify this expression, and then we get negative 1 negative lambda, lambda square minus lambda minus 2 minus 4 equal to 0. Next, we continue. Here we simplify in this bracket. We get negative 1 negative lambda, lambda square minus lambda minus 6 equal to 0. And we take out the calculator and we press EQN, and we get negative 1 negative lambda, lambda minus 3 lambda plus 2 equal to 0. If our matrix 3 by 3, it means we have 3 roots, 1, 2 and 3. And then we simplify. Negative 1 minus lambda equal to 0. Lambda equal to negative 1. Lambda negative minus 3 equal to 0. Lambda equal to 3. Lambda plus 2 equal to 0. Lambda equal to negative 2. For the question, is asked the largest eigenvalue. And now here we have 3 eigenvalue, and we conclude that lambda equal to 3 is the largest one. And now the largest eigenvalue is lambda equal to 3.
Hello, I'm Vishesh, and I'll be continuing part 2 for question number 2 for this assignment. So previously, as we know, we have calculated the eigenvalues for this matrix B. So the eigenvalues are negative 1, 3 and negative 2. And as per the question wants the largest eigenvalue. So the largest eigenvalue is obviously 3. So after determining the largest eigenvalue, we shall now proceed in finding the eigenvector. And the first step is to just substitute this 3 into the characteristic equation, which is this equation right here. So after substituting 3 into this matrix, we shall get this matrix. And next, we shall perform ERO on that matrix to get the echelon matrix. So now, we are calculating the echelon matrix so that the echelon matrix will later on help us in finding the eigenvectors for this question. So the first step is to switch this negative 4 into our pivot. So a pivot need to be 1, so this negative 4 should be 1. So we shall just divide this whole row by negative 4, and we shall get our new row 1, which is 1, negative 1 over 4 and 0. So since we have established this 1 to be our pivot, so everything below our pivot should be 0. So this 1 should be 0. This row 3, 0, it remains 0. So we shall focus on row 2 now. So this row 2 we shall just minus with row 1, which will give us 0, negative 3 over 4 and 1, hence making the elements below this pivot of row 1 to be 0. So next we shall focus on row 2 because we finished with row 1. So this row 2, the leading edge element, which is negative 3 over 4, should be our next pivot. So to switch this into 1, we just multiply the whole row 2 with negative 4 over 3, R2. So after multiplying negative 4 over 3 with this row 2, we shall get 0, 1 and negative 4 over 3. So we already determined that row 2 pivot is this one, so everything below this one should be 0. So this 3 also should be 0. So an easy way is to just minus row 3 with the row 2, which is multiply by 3. So after doing that, we shall get the whole row 2 is equals to 0. So this is our echelon matrix. Now to emphasis more on echelon matrix, the echelon matrix 0 rows are always at the bottom of the matrix. So this is our 0 row and it's obviously at the bottom of the matrix, and our pivot is always at the most left, and the most left pivot, which is this one and this, the value should always be 1. So this is obviously an echelon matrix. So the next step is to derive two equations from our echelon matrix. So the first equation is x minus 1 over 4y equals to 0, and y minus 4 over 3z equals to 0 from row 1 and row 2 respectively. Now we can see this echelon matrix has a rank of 2 because there's 2 non-zero rows. So we should get an infinitely many solution because we get our variables to be found is 3, which is x, y, z. So to prevent that, we shall just switch one of the x, y, z variable with our arbitrary complex, which is t, and we shall choose the latter variable, which is z. And after substituting t into z, we shall use the new z value, which is t, into our second equation, and we shall get y minus 4 over 3t equals to 0. So our y value is 4 over 3t in terms of our arbitrary constant. So after finding y equals to 4 over 3t, we shall just plug in into our first equation. So we shall get x minus 1 over 3t equals to 0, and finally our x is 1 over 3t, also in terms of t, our arbitrary constant. So the next step is to just plug the xyz value in terms of t into this equation. So our xyz, just plug in the value 1 over 3t, 4 over 3t, and t. So as we know, our eigenvector cannot be in the form of our arbitrary constant multiplied in, so we shall just factor out our arbitrary constant, which is 1 over 3, 4 over 3, and 1. So after doing that, this is our eigenvector in terms of the lambda equals to 3, which is our largest eigenvalue, hence satisfying our question. Thank you. That's all.